that you can really never get too much practice on. So
Yeah.
we'll put you to the test, okay? I'm going to give you quadratics and let you factor them.
Uh,
Would you factor that?
okay. X plus 3.5x plus 5.
I didn't quite hear that.
X plus 3.5x plus 5.
No, it's x plus 2 times x plus 5.
Oh, okay. Oh, yeah, okay.
It's important to realize what factoring is. Factoring is unmultiplying. In other
Yeah.
words, if I gave you these two linear factors and I said multiply them together, you would use FOIL, right?
Yeah.
And after you multiplied them together, you would get what I started with. So
Yeah.
what factoring really is unmultiplying. And it turns out that it's extremely important because if I write an equation and I set that equal to 0, now I can set these two things equal to 0. And that's hugely important because if I have one thing multiplied by another thing and it's equal to 0, one of those things has to be 0.
Yeah.
It's impossible to multiply two numbers together and get 0 unless one of them is 0.
Yeah.
So the reverse is true. If I have 2 or 3 or 4 or even 5 things multiplied together and it's equal to 0, then one of the things that's being multiplied has to be 0. So I solve this by saying, well, this is either equal to 0 or that's equal to 0, which means x is equal to minus 2 and x is equal to minus 5. So that's the advantage of knowing how to factor, is that when you have a quadratic that's equal to 0, you can factor it to solve it. And there's really no other way to solve that. In other words, if I start with that and I say that quadratic is equal to 0, you have no way of solving it without factoring. Okay? I'll give
Yeah.
you another one. And I'm not sure what method they've used to teach you factoring, but I'm going to show you my method.
Okay.
Are you familiar with the terms California method or diamond method or any of those words?
No.
Good. And I say good because those are horrible methods. They're complicated, they're confusing, and they're harder than my method. So let's go through my method. First of all, when you have a first level quadratic, and what I mean by first level quadratic is the coefficient of the x squared term is 1. Okay, it's not 2, 3, 4, any number other than 1. That is what I call an elementary quadratic, and it factors rather easily. Step 1, split up the x's.
Okay.
And what that basically means is x times x. Because remember, when I FOIL these two things back together again, the very first term is going to come from multiplying this by that.
Okay.
Okay? So, and if it's a first level quadratic, it's always going to be a 1, so it's always going to split to x and x. So that's pretty easy.
Yeah.
Second step, and this is the one everybody wants to skip. And I don't know why, but it's the most important step. Determine both signs. In other words, we're going to have a sign right there, and we're going to have a sign right there that's either plus or minus. What must both of them be?
they both must be the same, correct?
Correct. That's a start. They both have to be the same because otherwise they wouldn't be able to produce a plus 25 there. Remember where this plus 25 comes from. It comes from the final L of FOIL. In other words, multiplying that number by that number with their signs. So if I have a plus times a plus, that equals a plus. If I have a minus times a minus, that equals a plus. The only thing I know for sure is that it's not opposite signs. Okay? And by examining that plus, I know the signs have to be the same. And then if I examine that minus, that means they both have to be minus. The only way you produce a middle term that's negative is if both signs are minus. Okay? Yeah. Now, step 3. Factors, and I'd kind of like you to remember it this way. Factors of the constant, which in this case is 25, that do what? That add, because of that plus sign, these factors. First of all, you know what factors of the constant mean. Give me factors of 25. There's one. What's another set of factors of 25? 5 and 5.
Yeah.
That's the only two set. In other words, 25 times 1 or 5 times 5. There are no other two numbers that multiply together to give you 25. So being able to factor a number is pretty important, and we'll go through that in a second, how to factor a number. But look at this third step. Factors of 25 that add or subtract, depending on whether that is a positive or a negative sign. If that's a negative sign, then they need to subtract. But if it's a positive sign, they need to add to the number 10. So they need to add or subtract to the coefficient of the x term. So which two factors work?
5 and 5.
Yeah. Now, I'm going to erase these 3 rules because I need room to write.
Yeah.
Always check your answer. In other words, if we want to make sure we factored this thing right, well, we need to multiply this by this and see if we get what we started with.
Yeah.
But the secret is you really don't need to do the entire FOIL. You've been taught FOIL, right, that term?
Yeah.
Okay. In other words, the x squared term I'm 100% sure of. The plus 25 I'm 100% sure of. The only term that I have a little bit of doubt about is that middle term right there. Well, the middle term comes from the O in FOIL, which is the outside, added to the inside. Well, notice what the inside is. Minus 5 times x. The outside is minus 5 times x. Add them together, you get minus 10 times x, and that is our middle term. And that's all I need to do to check it. I don't need to actually FOIL it totally. I just need to make sure I have a correct middle term. Merely because the whole process I used to factor it was one that I started out by breaking up the x squared, so that's why I'm 100% sure of that. And then I ended by finding factors of 25, so I'm 100% sure of that. The doubtful part is that middle term. And we'll talk more about that in a second. Let's talk about factoring numbers. Factor 64. Always start with that, okay?
8 and 8.
Well, I want to give you a methodology for factoring it that works really nice in finding every single factor.
Factor trees.
Well, cut 64 in half for starters, if you can,
31.
which means I got to double that. So 2 times 32 has to be the same as 1 times 64, right? Now you can do it again. Cut 32 in half.
16.
16 times 4 is also equal to 64. Now I can keep going. I got 8. Cut that 16 in half and double 4. That gives you that. Now can I do it again? Well, if I do it again, I get 4 and 16, but that's the same two factors as that, so I'm not really gaining anything. And if I do it again, I get 2 times 32, which I've already got up here. So I believe I have all of the factors of 64 in the test. Okay? Now, let's take a different number that is not an even number. Let's take 27. Okay? Well, always start with 27 and 1. I cannot cut 27 in half and have it be an even number, or an integer rather. But what I can do is cut it in thirds. Okay? If I take a third of 27, it's 9, which means I got to multiply the 1 by 3. So 3 times 9 is 27.
Yeah.
Turns out that's the only set of factors for 27. Okay? Now, let's take a number like 50. So tell me the factors of 50.
Well, we have 25 and 2.
Start with the top, because 50 times 1, that's a set of factors, always.
Alright, 25 and 2.
Okay, in other words, cutting 50 in half gives you 25 and 2. Can't cut 25 in half, can't cut it in a third, can't cut it in a fourth. What can I cut it in?
Fifths.
So I cut that in a fifth, multiply that by 5. That's it. That's the only factors of 50. So in other words, you start by trying to divide that in half. If you can't divide it in half, you try to divide it by a third, and then it's not, if you can't divide it by a half, you're not going to be able to divide it by a fourth. But then you want to try a fifth or a seventh. In other words, if I gave you number like 98, factor 98 for me.
Okay, let's see.
What's half of 98?
Half of 98 is 44.
49.
Oh yeah, 40. Oh yeah, sorry, 49.
So 49 by 2 is one set of factors. Now look at the number 49. I cannot cut it in half. I cannot cut it by a third. I can't cut it by a fourth, a fifth, or a sixth. But I can cut it by a seventh.
Yeah, 7/7.
So if I'm cut it by a seventh, I have to multiply the 2 by 7. So that's 2 more factors of 98. And now I can't really cut the 7 by anything. It's a prime number. So that's my set of factors. And that's basically how you factor numbers, okay, is through that process. In other words, you start with 1 times the number, try to cut the big number in half. If you can't do that, try a third, and then a fifth, and then a seventh, and then a ninth, and so forth and so on.
Yeah.
Okay? All right, let's go back to factoring because there's still a couple here that are a little harder than my first three steps. What if I add this?
X squared minus 3x.
All right.
Well,
What's step one?
factor the x's.
Split the x's.
Yeah.
Split up x's. And I call it that because when we get to harder quadratics, there might be a coefficient. In other words, if that's a 2, then when I split up the x's, I get 2x times x, right?
Yeah.
Well, in the elementary quadratics, where this is always a 1, there's only one choice for step 1. It's always x times x. Step 2 is what?
It's distribute the
Not yet. Determine both signs.
Yeah.
And that's really important. If you can remember these steps, it's going to make solving quadratics so important. Well, what are both signs here? How can I possibly produce a minus 10? What do both signs have to be?
Negative. Oh, wait.
Yes, you're right. One has to be negative, one has to be positive.
Yeah.
They have to be opposite.
Yeah.
And I know that immediately by examining that only. And it's either plus minus or minus plus. Turns out they're the same. There's no difference. As long as it's x and x, then plus minus is the same as minus plus.
Yeah.
Okay? Step 3. What was step 3? And I want you to learn to verbalize this, because once you learn to verbalize it, it'll be much easier to memorize. Factors of what that do what?
Factors of 10 that they,
Add or subtract? Subtract. In this case, they're subtracting because that's a negative sign.
Yeah.
So I need factors of 10 that subtract to 3. That's all I'm looking for.
Alright.
Okay, well, let's list factors of 10. What is another set?
5. No, wait. We can just go. Yeah, 5 and 5.
5 and 2.
Oh, yeah. Yeah, sorry.
If I cut 10 in half, I got to double the other one.
Yeah.
Okay, well, there we go. There's factors of 10 that subtract to the number 3. Okay, so I found my two factors. Now, in this case, there is a fourth step. And that is you take the larger of your two factors and you put it with the sign of the middle term. Well, the sign of the middle term is negative. So my 5 goes there. My 2 goes there.
Okay.
Straightforward. And now, what do I have to do to check to see whether I factored it correctly?
We need to
use what I call the double smiley face method.
Okay.
Okay, which is multiplying the inside terms and the outside terms. And then adding those together and see if I indeed get minus 3x. Well, what are the inside terms multiplied to?
They multiply to 2x.
Plus 2x. I'm going to put the sign there just because I know I'm going to have to add it. What are the outside terms multiplied to?
Minus 5x.
Add those two together. What's plus 2x? What's that?
Oh, we have minus 3x.
And that is our middle term. So that shows that we did it properly. And that's the only thing I need to do is check the middle term. The reason is that I know x times x is equal to x squared, so I don't need to check that. I know
Yeah.
that 2 times 5 is going to be equal to 10. I don't need to check that. But there is one term, and that's this middle term, that you have to do two things to produce. And you produce that middle term by multiplying the inside terms together and the outside terms together and adding those two things together. So
Alright.
always the check stage. And checking is extremely important because as soon as we start talking about quadratics that look like something like this, the moment I get a quadratic that's no longer elementary, in other words, it's got a coefficient other than 1 in front of the x squared term, well, now this becomes much harder to do, and it involves a lot of trial and error, and almost all of the trial and error is figuring out how to produce that middle term. So when you're solving these, you use this check method. That's the only way to solve them, is you have to see whether you are producing the middle term properly. And so what becomes verifying your solution with an elementary quadratic becomes a very necessary step in a secondary level quadratic.
Alright.
I don't call it secondary because that's a 2. Anytime this number is other than 1, it makes this quadratic a lot harder to factor. And it turns it into a trial and error process. And most of the trial and error is figuring out how to produce the middle term. Okay? And we can talk about that later. Let's see. You have a 5:30 session, right? For a half hour tonight?
Maybe. I don't entirely know.
Well, you and your sister have a 4:30 and a 5:30 session.
Okay.
So usually I have a 5 o'clock session in between the two of you. Tonight I don't. So I can give you a choice. I can either let you go rest for a half an hour and come back on, or we can just go ahead and do that half hour now and get it
Let's
over
do it.
with.
I say we do it now.
Okay, let's do it. So
Yeah.
let me give you a few more elementary quadratics just to make sure you get these.
Alright.
Quadratics are the one thing in algebra that you absolutely have to master, is factoring quadratics. And it's one of the things that people have the most trouble with. If you can master factoring quadratics, you're halfway through algebra already. And I mean that with every bit of seriousness. That's how important quadratics are. Not everything you learn in algebra is going to be required for you to know in future levels of math, but factoring quadratics is one of them. Okay. So what's step 1 here?
We need to split the x's, so it would be x and x.
What's step 2?
Like,
figure both sides.
yeah. So they're both minuses, so we need a plus and a minus.
A plus and a minus. In other words, they're both opposite.
Yeah.
Because I cannot produce a minus 12 unless they're opposite. That's the only way I can get a minus 12. If they were both the same, that would be a plus, whatever. But it would be plus. So when I see a minus, I know the signs have to be opposite. Okay? That's step 2. What's step 3? Verbalize it for me.
The 12?
factors of 12 that do what?
That also can factor into the x.
Here's the way I'd like you to remember step 3.
Okay.
Factors of 12 that subtract because of that negative sign. If that was a positive sign, they'd have to add. Okay?
Yeah.
The coefficient of the x term. What's the coefficient of the x term?
Negative.
I don't really care about the negative. I just care about the 1. So
Yeah, because
I'm really looking for factors of 12 that subtract to the number 1. Well, let's list factors of 12. What do we got? 12 and 1, what's the next?
6 and 2, and then 4 and 3.
Which ones subtract to the number 1?
12 and 1.
No, these two factors have to subtract to the number 1.
Oh, 4 and 3 then.
Yeah. And which one goes where? In other words, you've done the first 3 steps. We found the factors. But because it's a plus and a minus, we have to put one of those factors with the plus and one of them with the minus.
The 4 is larger, so it goes in front of the plus.
Ah, you're close. The 4 is larger. It goes in front of the sign of the middle term.
Ah, okay.
Middle term is minus, so the 4 has to go there.
Alright.
3 has to go there. Now, we check it by doing the double smiley face. That's plus 3x. This is minus 4x. Add them together, you get minus x.
Okay.
And that's the middle term, so we did it right.
Okay.
Okay? Do another few of those. When I say you cannot get too much practice at factoring, I mean it. I've never met anybody yet that has had too much practice at factoring. When you can do all of them perfectly and quickly, then you're done practicing. Okay?
Alright.
So let me make up a few more. Go through with all of the steps.
Okay, we need to split the x's.
So tell me how to split them, because sometimes it's not going to be obvious.
Well, we take the x squared and put 1 x in each column.
Okay, so it's x and x.
Yes, and we determine
Let's just go back a second so that you understand why I said what I just said. If that was 4x squared,
we need 2x and 2x.
not necessarily. I could also have 4x and x.
Oh, okay, yeah, because they're both x.
Sometimes there's different ways to split this term up when you get into higher level quadratics. It's only on the really simple ones that it's automatic. In other words, when it's x squared, it only splits up as x and x. That's the only choice.
Okay.
Okay? Now, second step.
We need to determine the sign.
Good. I want you to remember these steps, because if you can remember these steps, you will not have any problem with factoring. What are both signs?
They are
First of all, are they the same or are they opposite?
They are opposite.
Hold on. I can't produce a plus 25 with two opposite signs.
Oh, well,
If one's a plus and the other's a minus, this number is going to be minus, always.
okay.
So remember that when you FOIL, you're multiplying that times that, and the very last process of the FOIL is multiplying that times that. That's what produces this number that I've circled. So that's why I know that both signs have to be opposite. or excuse me, the same. In this
Yeah.
particular case, they have to be the same. I could either have minus minus or plus plus. Either one produces a plus, right?
Yeah.
Even if I had minus minus, I'm going to produce a plus. Well,
Mm-hmm.
if I know that it's either minus times minus or plus times plus, how do I tell which one it is? Look
It's
at the
basically the
sign on the middle term. What is it?
plus.
The sign on the middle term.
Oh, it's minus.
Ah, that makes it minus minus.
Yes.
If the sign on the middle term was plus 10x, then it
Then
would
it'll be
have to be plus plus.
yes.
But as long as it's not a plus, then the only possibility is it's got to be minus minus. And in this case, there's only one more step. There's not 4 steps in this one. There's only 3. What's the third step? Verbalize it for me.
It's
Starts factors of.
yeah. We factor the 25.
So the third step is finding factors of 25 that do what?
What was that? You lagged out.
Factors of 25, always started out like that add, because of that plus sign, to the number 10. Well,
Yeah.
let's list factors of 25. The only way I can break that up is that way. So what 2 factors add to the number 10?
We need 5 and 5.
Yeah, and notice that I don't have to decide which one goes where. Because both signs are the same, I can, if I had to come up with 10 and 2, I could have put the 10 over here and the 2 there, or vice versa. Wouldn't have mattered.
Yeah.
So there's no 4th step when you have both signs being the same. There's only 3 steps. And it's actually easier. If I change this problem to a minus 25, and I change this to a, hold on, minus 24x, now factor it for me. Well, let me erase some stuff. Hold on. I'm mastering this program. Okay.
Yeah.
So it starts out with x and x.
Yes.
X, what are both signs?
We need 10 and 2.
Are the signs the same or are they opposite?
They're opposites.
So plus minus or minus plus.
Yes.
And it's not going to matter which I put first, not on these elementary ones.
All right.
What's the third step?
Factors
of
factors of 25 that will add to 24.
Not add.
Oh, multiply.
Subtract.
Wait.
In other words, you always do whatever
Yeah, because okay.
is. So I want factors of 25 that subtract to the number 24. Simple
Okay.
as that. Okay? Well, here's my factors of 25. Which set subtract to the number 24?
25 and 1.
Which one does the 25 go on and which one does the 1 go with?
The 25 goes on the minus.
Yeah, the larger factor goes with the sign of the middle term. And this is why. Because I produce the middle term by this, and that's 1x, and this is minus 25x. Add those two together, you get minus 24x. That's why you have to put the larger factor with the sign of the middle term, because the sign of the middle term, in other words, the larger factor always rules. Right?
Yeah.
In other words, if the 25 is with the negative sign, I got minus 25x, I only have plus 1x. So the middle term is going to be negative.
Yes.
Okay, good. I think we're making progress here. Have to now. We got 15 minutes. Let's at least look at some harder ones.
Okay.
Just so that you can see why they're harder. Now, hold on a minute. I got to think for a second.
Okay.
Now, this is not an elementary quadratic anymore because it has a coefficient in front of the x squared that's not 1. And that actually makes a huge difference. So break up this term. In other words, the first two terms of my answer have to multiply together to give you 2x squared. So what are the possibilities?
Okay.
Only one. There's only one possibility.
X squared on each side. No.
How about 2? Always break up the x.
X.
Okay? And this one only breaks up as 2x times x. And I could put the x there and the 2x over here, but that's not going to matter. The fact is that I got to break up the 2x.
Okay.
And I don't have any choice. There's not any choice on the factors of 2. It's 2 times 1. That's it. So it's not like when I put a 4 there, I could have broken it up 2x times 2x or 4x times x. And it's true, the bigger that number gets, the more complicated the problem gets. What's the second step? The first step is the same, break up the x squareds.
Yeah.
Second step is actually the same also. What was the second step before?
Determine the sign.
What are the signs here?
Minus and minus.
No, minus and minus would give me a plus 10. They cannot be the same. In other words, the way you figure both signs is to always examine the sign on your constant. Well, I can't produce a minus 10 with two signs that are the same. The only way I can produce a minus 10 is if one sign is plus and the other is minus.
Okay.
Okay? But in this case, plus minus is not exactly the same as minus plus. You'll see why. They're going to give you different answers. So the moment we get to secondary quadratics, kind of throws out all of the method we used in elementary quadratics. Elementary quadratics are really easy when you learn those 3 or 4 steps. Secondary quadratics are a lot harder because you have to allow for both the plus minus or the minus plus. Now, the third step is factors of 10, but that's as far as I can go. I cannot say anything else. I can't say that they have to add to the number 9. I can't say they have to subtract to the number 9. I just can't say it. I got to try all of them. Okay? So let's start with, and this is just random trial and error at this point. And I always start with the two factors that are closest together. 5's closer to 2 than 10 is to 1, right?
Yeah.
That's just a general rule. It doesn't mean that that's going to be the answer. It just means that all the problems you're going to get in Colorado, the answer is going to usually be the two factors that are closest together.
Okay.
Okay? Now, is that the answer?
Plus 5 minus 2.
And the way to determine whether that's the answer or not is, does it give us the correct middle term? That's the only way to determine it. Well,
yeah.
what's this part?
It's plus 5x.
What's the bottom part?
Minus 2.
Minus 4x, right?
Minus 4, wait.
Times 2x.
Oh, yeah.
Okay,
Yeah.
those add to plus x. Now, here's the thing. That's not the right sign, and it's not the right coefficient. So I know this isn't correct.
Yeah.
Okay? Well, notice that if I move the 5 down, it doesn't change anything but the sign. In other words, if I try that, I still have a minus 5x and a plus 4x, which gives me minus x instead of plus x. So it changes the sign on that, but it doesn't change the number. So I don't need to try that solution. In other words, the moment the 5 and the 2 don't work in this, I don't try it. I go to 2 and 5. Excuse me, that was supposed to be 8 right there. Apologize. It's hard for me to figure out these complicated quadratics because I don't factor it when I make them up off the top of my head.
Yeah.
Now, this, as I've said, is a trial and error. So I'm going to, just for this example, try 2 and 5 like that.
Okay.
What middle term does that produce?
That produces
On top?
minus 2x and plus 10x.
Which produces what? Add those two.
Negative 9. Oh, no. Positive 9x.
Well, positive 8x, right?
Yeah.
Well, that's the right number, the wrong sign.
Yeah.
So all I have to do is move the 2 up to there and the 5 up to there, and that's going to give me the same number I just got, only the opposite sign, which is what I want. So let's check this one. In other words, I'm saying that this has to be the right answer. 2x plus 2 times x minus 5. And the way I check it, always, again, I don't need to check that term because of the way I did the problem. I don't need to check this term because of the way I did the problem. I just have to make sure that we produce a minus 8x in the middle. Well, by moving it up, that becomes plus 2x. This becomes minus 10x. Add those two together, and you get the same number 8, but now you get a minus sign in front of it. That's the answer. So my answer is 2x plus 2 times x minus 5. And if I FOIL those two things together, I'm going to get this quadratic. Okay? So the one thing you can kind of see here is that once you get beyond elementary quadratics, it's really tough. It's a trial. In other words, the moment I lose the ability to write plus minus or minus plus is the same, then it becomes a lot harder. Now, let me think of one other problem. Let me figure out, yeah, this will work. Hold on. I knew what I was thinking and I forgot it in an instant. Hold on a second. Let me figure out what I was thinking. I was thinking, yeah. And hold on a minute. All right. Let's take that quadratic right there.
Alright.
First step.
We need to split the x's.
And I have two choices. I can do 2x times 2x, or I can do 4x times x. Well, remember what I said. When you have choices, always choose the two factors that are closest together. It's not going to guarantee that that's the right answer, but it's much more likely to be the right answer. If this is not the right answer, then I'll start the problem all over again, trying 4x and x. That's the way these go. They're trial and error. Second step.
We must determine the sign.
Okay, what are both signs got to be?
They are going to be negative, positive.
Correct. Now, in this case, negative positive is the same as positive negative, only because the coefficient of the x's are the same. In other words, as long as these coefficients are the same, plus minus is the same as minus plus. So I don't actually have to allow for both. I can just put one. Okay?
Yeah.
Now, the third step still starts with factors of 15, but that's as far as you can go. You can't say factors of 15 that subtract to the number 4 or factors of 15 that add to the number 4. You cannot do that. Once you get into secondary quadratics, you can only go factors of 15. Well, what are the other factors of 15?
They are 5 and 3.
Okay. Let's try these first because they're closest together. Okay? And there's really only one solution. Either it's 5 there and 3 there, or 3 here and 5 here. Well, let's start with 5 and 3.
Okay. Yeah.
Produce this as a middle term.
530.
Sorry, what?
Oh no, my mother was calling me.
Oh, okay.
Yeah.
Yeah, we'll be done with this problem. Let's see if we can finish this problem.
Alright.
Does this answer work? In other words, that's always what you have to ask when you're factoring quadratics. Does your final answer produce this quadratic? Well, I know it produces the 4x squared. I know it produces the minus 15. Does it produce the minus 4x in the middle? And the only way to check that is this method here. It's this.
We get negative 10x and positive x.
Add them together.
We get negative 4x.
So that's the correct way. Now,
Yeah.
before we leave the problem, I guessed at that. What if I would have put the 3 here and the 5 there instead? Well, now what does that produce? Minus 6x there, plus 10x there. Add them together, you get a plus 4x. You get the right number, the wrong sign. Well, that's easily remedied. Switch the numbers. In other words, if you get the right number, 4, but the wrong sign, plus, then go back and put the 5 there and the 3 there, and you'll get the opposite. Okay? That's factoring. That's a good hour session on factoring, and hopefully you learned quite a bit from this session. because
Yeah.
factoring is a skill that you are going to need.
Yes.
Absolutely. No
Yes.
getting around it. So,
Uh-huh.
Nick, thank you. I will talk to you next week at 5:30.
All right. Sounds good.
All right. Have a good week.
Bye.
Bye-bye.